solve y power 4 plus 2y into dx plus xy cube plus 2y power 4 minus 4x into dy, which is equal to 0. Here procedure is same as before problems. Take the given problem and this is the equation of the form m dx plus n dy, which is equal to 0. Identifying m and n value, here m is y power 4 plus 2y and n value is xy cube plus 2y power 4 minus 4x. After finding m and n value, we have to find del m by del y and del n by del x. Here del m by del y is nothing but partial derivative of m with respect to y. Here differentiation of y power 4 is 4y cube plus differentiation of 2y is 2. Similarly, del n by del x is, here y cube is constant, take as this, into differentiation of x is 1. Here no x term, so neglect this value. Here we have minus 4 is constant into differentiation of x is 1. Observe this, del m by del y is not as same as that of del n by del x. Therefore, we can conclude that del m by del y value is not equal to del n by del x. This shows that the given differential equation is not an exact differential equation. To reduce this to an exact differential equation, you have to find the integrating factor. For that, first find del m by del y minus del n by del x value. Here del m by del y value is 4y cube plus 2 minus del n by del x is y cube minus 4. Here minus sign inside the bracket, multiply and simplify, we get as, here 4y cube minus y cube is 3y cube plus 2 minus 2 minus plus 4, hence we get as 6, which is equal to, if we take 3 outside the bracket, we get as 3 into y cube plus 2. So observe that del m by del y minus del n by del x value is this. This is close to the value. This, if we take y common, we get as y into y cube plus 2 here. Hence this is same as this. Hence we have to multiply this del m by del y minus del n by del x value with 1 by m. Hence we get 1 by m value is y into y square plus 2. Take y as common here. We get as y into y cube plus 2 into the del m by del y minus del n by del x is 3 into y cube plus 2. Hence we can cancel this y cube plus 2, so that the remaining is 3 by y. This is a function which contains only y, so we can take it as g of y. Therefore, the integrating factor is exponential power of minus integral of g of y into dy. Substituting g of y value, that is e power minus of integral of 3 by y into dy. Here take 3 outside the bracket, we get as exponential minus 3 into integral of 1 by y into dy. We know that integral of 1 by x into dx value is log x. In the place of x we have y. Therefore we get exponential power of minus 3 into log y. Here take this minus 3. Here we get as, this is of the form n log m. Therefore we can take it as log m power n. Here exponential and log gets cancelled. This is y power minus 3. Hence we get an integrating factor is 1 by y cube. If we take y power minus 3 to the denominator, that becomes 1 by y cube. This is our integrating factor. Once we obtain an integrating factor, next step we have to multiply the integrating factor to the given differential equation. Here the given differential equation is this. Multiplying this with an integrating factor 1 by y cube, we get as, here 1 by y cube into y power 4 is, here y cube gets cancelled, remaining is y, plus here 2y by y cube. So 1y gets cancelled, the remaining is 2 by y square into dx. Multiply inside the bracket carefully. We have to multiply this integrating factor for this factor, also for this factor. Here xy cube into 1 by y cube, that is xy cube by y cube. Here y cube gets cancelled, remaining is x, plus 2y power 4 divided by y cube. Here y cube gets cancelled, remaining is 2y, minus 4x by y cube as it is into dy, which is equal to 0. This is a differential equation because this is of the form m dx plus n dy, that is m dash dx plus n dash dy, which is equal to 0. Take m dash as y plus 2 by y square, n dash is x plus 2y minus 4x by y cube. Next step, find del m dash by del y and del n dash by del x. We get as del m dash by del y is nothing but partial derivative of m dash with respect to y. Therefore differentiation of y is 1, plus 2 is constant, take as it is, into differentiation of 1 by y square is minus 2 by y cube. That is, if we take y square to the numerator, that becomes y power minus 2. This is of the form y power n. That is, differentiation of y power n is n into y power n minus 1. Hence we get minus 2 into y power minus 2 minus 1. Hence we get as minus 2 into 1 by y cube, that is minus 2 into 2 is 4 by y cube. This is our del m dash by del y. Similarly, del n dash by del x is partial derivative of n dash with respect to x. The differentiation of x is 1. There are no x terms, so neglect this value. Here minus 4 by y cube is constant, take as it is, into differentiation of x is 1. Hence we get 1 minus 4 by y cube. Observe this, del m dash by del y value is 1 minus 4 by y cube. Del n dash by del x is also 1 minus 4 by y cube. Therefore, we can conclude that del m dash by del y value which is equal to del n dash by del x value. Therefore, the obtained differential equation is exact differential equation. Next step, the solution for an exact differential equation is integral of m dash of x comma y of dx plus integral of terms which does not contain x in n dash into dy which is equal to 0. Here m dash is y plus 2 by y square, n dash is x plus 2y minus 4x by y cube. Here for this, substituting this value, we have to take the finally obtained exact differential equation, not the given problem. Finally obtained exact differential equation. Using that, we have to take m dash and n dash value and substitute here. Here integral of m dash of x comma y of dx is y plus 2 by y square into dx plus terms which does not contain x in n dash. Here n dash is this. Terms which does not contain x is here also x term, so neglect this value. Here no x term, so take it as 2y. Here also x term, so neglect this value. The remaining is integral of 2y dy which is equal to 0. Next, expanding the integration, we get as here this is y plus 2 by y square, this is constant, into differentiation of 1 into dx is x. So multiply x inside the bracket and simplify, we get as y into x plus 2 by y square into x plus here 2y into dy. Here 2 is constant, take as it is, into integration of y is y square by 2 which is equal to c, some arbitrary constant. Here 2 gets cancelled and take LCM as y square and simplify, we get as here y square into yx is xy cube plus 2x plus here y square into y square is y power 4 which is equal to c.